Hi guys, my name is Andres Sava, and today we're going to be discussing the acid-base reactions using an experiment of the eruptive volcano. The materials that we'll be using today will be baking soda and vinegar. What is a weak acid? Weak acids are acids that don't completely dissociate in solution. In other words, a weak acid is any acid that is not a strong acid. The strength of a weak acid depends on how much it dissociates. The more it dissociates, the stronger the acid is. Dissociation is how many hydrogen ions can be produced in an aqueous solution. So a weak acid is that doesn't produce many hydrogen ions when in an aqueous solution such as water. Weak acids have relatively low pH values and are used to neutralize strong bases. Some examples of weak acids include acetic acid, which is vinegar, lactic acid, citric acid, and phosphoric acid. A weak base is a basic substance that do not completely ionize in water. An example of a weak base is ammonia. When ammonia is dissolved in water, a part of it dissociates into ammonium cation and hydroxide anions by interacting with the water molecules. A weak base is a base that, upon dissolution in water, does not dissociate completely, so that the resulting aqueous solution contains only a small proportion of hydroxide ions and the concerned basic radical and a large proportion of undissociated molecules of the base. Some examples of weak bases are sodium bicarbonate as baking soda, magnesium hydroxide as antacids, such as milk of magnesia, and aluminum hydroxide as deodorant. Some characteristics of weak base is that the substance carrying a weak base has a pH of more than 7. A weak base is capable of making changes to its indicator's color. A weak base sometimes causes irritation and skin burning. It is bitter and shiny on the skin. Although weak, they conduct an electric current. A weak base can neutralize weak acidic solutions. What is the reaction now that is happening with the vinegar and baking soda? So we have the vinegar, which is the acetic acid, reacting with the baking soda, which is sodium bicarbonate, producing sodium acetate, water, and carbon dioxide as a gas. So in this experiment, we're going to see the reaction between the vinegar and baking soda. So at first, I tried to use a paper towel to put the baking soda inside in order for me to not have a quick um, reaction, and this happened. I put inside the baking soda with the paper towel, and inside the water bottle I have vinegar, which is filled up to halfway. We see the carbon dioxide produced, as we can see the foam and the bubbles in the bottle. But because I added the baking soda inside the paper towel acts as a shield or barrier for the baking soda, so there is not an actual contact between the vinegar and the baking soda. So I repeated the experiment again, and instead of using baking soda inside the paper towel, I tried to dissolve the baking soda in water before pouring the baking soda inside the battle with the vinegar, and this happened. As we can see, the volcano was success. Um, the reaction was much quicker than the one earlier with the paper towel because the two compounds came to uh, close contact with each other. So the volcano erupts because of the chemical reaction between an acid and a base. The acetic acid present in the vinegar reacts with the sodium bicarbonate, which is the baking soda, and produces carbon dioxide, as we said earlier. The base, sodium bicarbonate, undergoes a decomposing reaction which is exposed to the acid. This produces a gas called carbon dioxide, which causes the homemade volcano to erupt. The carbon dioxide escapes the solution as bubbles. The bubbles are heavier than air, so the carbon dioxide collects at the surface of the container or overflows it.